to at least get started with the lab and making some predictions, writing some hypotheses and things like that. So we've been talking about volcanoes and how volcanoes form, the different impacts that they have, the different shapes of volcanoes, magma versus lava. And so now we're going to talk a little more in depth about what causes them to erupt. So really what we see happening is there's a lot of dissolved gases, and these gases build up over time. Yeah?
Are we on the new set of notes, or is it still confusing?
Still the same. It's still the same with like the plate tectonics and the seafloor spreading. All this is kind of the same.
Okay, I just didn't know if y'all got a new set whenever I was going to.
I used to have it labeled as no heat too, and Sydney every year.
Yeah, so this all goes with the plate tectonics we've been learning, Pangea, seafloor spreading, all that. So dissolved gases, mainly water vapor and carbon dioxide, build up over time. And think of it as like when you shake up a soda. When you shake up the soda, you can actually feel the bottle expanding because all of that pressure is getting built up inside of it. The closer the gas gets to the surface, the less pressure to hold it down. So if you were to shake up a soda and then you just crack the lid or crack the can just a little bit, then it's going to come shooting out because that's where the pressure is the least. That's the area that can't hold it back anymore, and so it's going to release that pressure very, very quickly. That's basically what we're seeing happen with these volcanoes, is they get all this pressure that's built up underneath, and then they're going to explode upwards because the crust is the thinnest area, and it has the least amount of resistance for that pressure. Less pressure allows the gases to suddenly be released. Again, think of it as like shaking up a soda bottle. You crack open that soda, suddenly it all fizzes out. We've all done it. And that's because now the pressure finally has a release to it. Sometimes, depending on the volcano, depending on the landscape, it doesn't explode out, and it can more trickle out kind of slowly. And for the trickling out slowly, this is an advantage because it's not going to be explosive. It's able to relieve that pressure. Same thing with like opening a bottle. Once you open it and you realize it's squirting everywhere, you'll close it again. And then you open it really slowly. And that slowly releases the pressure so it's not going to explode out. Same kind of idea. Sometimes there's like ways that the gases can be dispersed without just the explosive force.
One time I shook up my friend's soda and then I let out half of the air and then I thought it was gone. I looked away and went down to the whole cap and just rolled me.
That's funny.
It happened this year.
Did it explode on you or your friend?
It was all of me.
Probably would have been fun if it was on your friend.
But there was like that much soda left in this bottle. And
By the time you're done.
yeah.
I am curious, after we put the Mentos in, how much soda will be left, and that's something we can predict as well.
Are we going on from like?
You know, we're gonna have bottles set because we need to be able to figure out like how much liquid was released, how far it shot up, and things like that. So
Can I at least rocket one of them if I buy my own?
you buy your own soda and you buy your own Mentos. We're gonna be out in a field. Probably we'll go to the old soccer field to do it. So we have a lot of space. We don't make a big mess.
It's going to be cold.
It is gonna be cold. I'll try and pick a good day to do it when it's not super cold. Because right now it's what, 45? That's still cold, but
It's not gonna get cold.
it'll be
Actually,
warmer
this
days.
weekend is supposed to be warm. I have to go to school.
Alright, so this video is just gonna kind of explain the eruption process and talk about volcanoes in general. Maybe.
Bottomless cauldrons fueled by an ancient wrath, bubbling and boiling thousands of miles beneath the surface, and just waiting to burst through. Volcanoes are scattered across the planet. About 1,500 active volcanoes can be found across the world, though countless others are on the ocean floor. Most volcanoes, whether on land or underwater, are located where tectonic plates meet. In fact, the Ring of Fire, a path that traces the boundaries between several tectonic plates around the Pacific Ocean, contains about 75% of the planet's volcanoes. There are several types of volcanoes, primarily classified by shape and size. Major types include stratovolcanoes, which often appear as tall, steep mountains, shield volcanoes, which are flatter and dome-shaped, calderas, which are large depressions in the ground, and mid-ocean ridges, which are underwater chains of volcanic mountains. No matter their shape or size, all volcanoes emit gas and molten rock. The journey of these emissions begins deep underground in the Earth's core. The core, which can burn as hot as the surface of the sun, transfers its heat to the surrounding rocky mantle. In doing so, the heat melts some of the rock. This molten rock, or magma, is lighter than the surrounding solid rock layer, so it rises through the mantle. The magma then escapes through vents in the Earth's crust, causing volcanic eruptions. Now above ground, this magma is referred to as lava, and it can reach temperatures of over 2,000 degrees Fahrenheit. In addition to lava, volcanoes may erupt with searing hot gas formed in the mantle. In a phenomenon called pyroclastic flow, this gas, combined with hot ash, can race down the sides of a volcano as fast as 100 miles per hour, burning everything in its path. To measure and classify eruptions, scientists developed the Volcanic Explosivity Index, or VEI. It considers various factors, such as the volume of lava, gas, and other emissions from the volcano, along with the height of the eruption cloud above the volcano's summit. The VEI scale begins at 0. Each successive measurement increases logarithmically, meaning that each magnitude is 10 times more powerful than the one before it. The VEI scale does not have an upper limit, but the most catastrophic eruptions measured thus far are categorized as VEI 8. These eruptions occurred thousands and millions of years ago. The most destructive volcanic eruption ever witnessed occurred in Indonesia in 1815. Mount Tambora, a large stratovolcano, erupted with a VEI measurement of 7. The blast caused earthquakes, tsunamis, and pyroclastic flows that decimated the land and took tens of thousands of Indonesian lives. The eruption even destroyed the top of Mount Tambora itself, turning the 13,000-foot tall mountain into a 3,640-foot deep caldera.
That'd be awesome.
While volcanoes are some of the most destructive forces of nature, they have also helped make life on Earth possible.
I was gonna be close.
Volcanic ash provides nutrients to nearby soil, making the land fertile. And lava, when it cools, hardens into rock and creates new landforms. With heat from the heart of the Earth, volcanoes have helped terraform the planet, making it the rich, dynamic landscape we see today.
Alright, so depending on the type of eruption, volcanoes may produce lava flow, the pyroclastic material, that's that ash they were talking about, but it's not just ash, it's gases, it's little pieces of rock, it's a combination of things. All volcanic eruptions emit large amount of gases, and sometimes those gases will kind of fall down the side. They call the volcanoes different names than what we're learning, and that's okay because they go by different names. We're learning the shield, and the cinder cone, and the composite one. I think they called this one a caldera. So basically the same thing. But the cinder cone is the most explosive because it only has one way to go. Composites are a little less explosive because it has those openings And shields are more gentle because it has the ability to kind of spread out that explosive gases and magma. So when a volcano explodes, you don't have to only worry about the lava from it. You also need to worry about how it travels, like the ash, for instance. If the ash plume goes really high, then it can be blown by the wind, and that ash can coat other areas. It can cover the vegetation, it can make it difficult to breathe, it could cause acidic rain. A lot could be happened in areas that surround the volcano, not just in the immediate area.
Did they say if Yellowstone was on go up, it wouldn't cover like all of the Northwest?
I think so, yeah.
They said there would be like ash in the air for like days.
Yeah,
Mhm.
to like the population of Lita. I think we need something like that.
Yeah, it's like
We need to chop our population down a little bit.
So that's an interesting idea. In nature, we don't really talk about ecology much here, but in nature there is always something that keeps animal populations in check. There's always something that prevents animals from going too high. Maybe it's a lack of resources, maybe it's a new predator. Something always prevents unlimited growth. The only exception to that ever is humans. And so the human population has continued to grow, and there is theories out there that it can't continue at this pace, that we can't continue to grow. The
We need to
reason,
drop. We need a war.
We need a purge.
Not purge, a war.
I don't, the problem is that every time we come up against a problem like lack of food, we figure out a way to solve that, like genetically modifying the food to produce more. Or maybe there is not enough habitat. Well, let's build a skyscraper so we can fit more people in a smaller space. Maybe people are dying from a disease like COVID, and so we figure out ways to combat that, like vaccines. So there is all kinds of reasons why we are doing as good as we are,
Yeah, because we're smart.
because we're smart. But it's true. But there is a lot of people who believe that something at some point is going to knock our population down, whether it's a natural disaster or whether it's something
It's
cause
necessary.
itself. The human population cannot keep going and be sustained with the rate we're going.
Because like the birth rate versus death rate, it's like this needs to be more like this.
And people
So
are living
COVID is
longer
necessary.
because of better healthcare. Babies that were born premature also living longer because of more technology and better care for them. So, more people are living that in the past would have died.
Einstein is necessary for this society.
I'm still holding on to the zombie apocalypse.
Actually? Do you think
Well,
they'll actually
you
eat
know there are
people?
zombie ants, right?
What do you mean?
You've never
There's
heard of
also
zombie
like those
ants?
worms and bugs that like are in fish. And
What do
birds.
zombie ants do?
Zombie ants are infected by a fungus that totally takes over the ant, completely takes over the nervous system, and the ant still appears to be alive, but they're completely overridden by this fungus. And then the fungus will eventually kill the ant, explode out of its head, and release like a mushroom and release its spores to go infect others. So it's a zombie ant, lives in the rainforest.
Yeah, they also have those
Really?
like, images of the ants holding down the other ants.
Are they
Because the
cannibalistic?
ants know that they're infected. So they will try and get rid of the infected ant because they don't want the spores to come and infect the rest of the
Are they
colony.
cannibalistic though?
The spores or the ant?
The ant. The zombie fight ant.
Technically, it's a like regular ant.
Yeah,
Does it
it's
eat
not that
these
it
others?
doesn't eat the others, it just, the others want to get rid of it before the mushroom explodes and the little mushroom spores infect them too.
No, but what does the mushroom do? This is perfect.
Takes over, it's the only way the mushroom can reproduce.
Yes. So it just feeds off the ant.
Yes.
I mean, think about it. We're like.
But what happens to the ant itself?
Ant dies.
Does it still function?
No, well, the fungus takes over his brain and makes it function. And then eventually it crawls up and it dies.
Yeah, they'll.
You have to look at it YouTube sometime, not right now.
Do you know the behavior of the ant when it's being controlled by the fungus? Like that's
It
what
acts like a normal ant. It like tries to fit in with the other ants.
The only thing you can tell
Oh.
the difference is will be mushrooms on it. So.
Seriously?
Yeah.
That's kind of cool. Are these like big ants?
You're gonna have to look at the video, but not right now. Alright, anyways, volcanic eruptions. There's different types of lava flow, and that's based on how fast it moves down the hill. Pahoehoe. That's how it's pronounced, I think. Pahoehoe. And a lot of these have like Hawaiian kind of names because Hawaii deals with a lot of volcanoes. Pahoehoe lava flow is hotter, faster moving lava. So this is moving really fast. It's really, really hot. So it looks almost like a river of lava. Then we have, oh, I forgot how that one's pronounced. I think it's pronounced I, which are cooler, slower moving basaltic lava. So this is kind of oozes. Think of it as kind of just oozing along. It's very hot, but it's kind of cooling itself behind it as it moves. So this would be an example of an I lava. They can also have blocky and pillow lava. This one right here is kind of pillow lava because it has cooled on top, and so it looks like a big cushion, but it's still hot underneath. So if you were to poke the surface, you would find the hot lava underneath that. So there are different types of lava flows depending on where the eruption happened, what kind of volcano it erupted from. Is it next to an ocean? Is it not next to an ocean? All of these things play into the type of lava that's going to happen from that eruption.
What is basalt?
It's based on the kind of rock. Basalt is a kind of rock.
Basalt?
Basalt. Well, it's kind of a rock that is a little bit like lighter.
Lava rock?
That's a pillow lava.
And that was the one, the pillow lava. It looks like a cushion, and the top surface is hardened, but underneath the lava is still lava.
Kind of like that.
Yeah, this one right here would be kind of pillow lava. This is more of the I lava.
Cute. It does look pretty comfortable.
I'd throw Caitlin into
It
a
looks-
volcano.
Looks like a
That
rubber
would not be a
fat
good idea.
bean.
Not very kind of you.
We already know Justin's not known for his kindness. Which I don't believe because I think Justin can be very nice when he wants to.
He can. Maybe probably just depends on food.
Alright, so this is in Google Classroom for you. So you have these different kinds. Here's the I one. This is the Pahoehoe one. This is the pillow lava. This one's kind of underwater, so it cools fast and makes kind of these smooth bumps. And then here's kind of blocky lava where it kind of forms in chunks and cools kind of quickly. So this is in Google Classroom, so you can refer back to it. Alright, now aside from the lava, the gas and ash produced can also have a huge impact on the environment. We already kind of mentioned this. That, yes, the major impact is going to be right near it, but those gases are going to be traveling through the atmosphere, and so you're going to experience things like acid rain, difficulty breathing, air pollution, ash coating the plants and making it difficult for the plants to photosynthesize. So there's a lot of things that go on from an explosion besides just the lava in the immediate area. And there's a lot of different gases that can explode out of it. Even though it's mostly carbon dioxide, that's not all of it. You've got nitrogen, sulfur, that's why it kind of has like a sulfur smell to it, that kind of bitter smell. Chlorine, hydrogen, and argon. So lots of different materials can be found in that, in the gases in the ash.
And a lot of minerals to help the soil grow.
Yeah, because it is beneficial. I mean, once everything settles down, it's returning a lot of those nutrients to the soil, which is a good thing. The destruction at first isn't necessarily good, but it's kind of like a forest fire. Sometimes you need to have a forest fire to get rid of all the bad stuff and all the undergrowth in order for the new stuff to be able to grow.
I think our earth would thrive without us.
Oh, I'm sure it would.
By a lot.
It's already been said by a lot of people that without humans, the earth would thrive a lot longer than it
Oh,
should.
yeah. Yeah.
Like, I think it would grow, like, so much more.
The earth would be a lot healthier place without us in it.
And we get way,
You're
it'd be a
right.
way thicker layer each year than it does now.
Yeah. We're kind of selfish.
self-preserving.
We really are. But
Well, we're gonna die
it's in
eventually.
our nature. It's in all animals' nature to be self-preserving. The idea of
Except for
actually
kangaroos.
sacrificing yourself is not something that's often found in nature. I mean, it's
Kangaroos.
there.
Ants. Kangaroos are stupid when it comes to learning to survive because they'll throw their own population down to save themselves.
We love to.
Did you know that a Komodo dragon would
Many animals eat their babies.
That's
At the zoo, we always hesitated
You were
to
starting to eat your
release.
child.
I'm not having children.
A lot of animals also just eat
What?
the placenta.
The Oregon Trail, is that what it was?
Oh, no, it was the Donovan family.
Denmark? No.
They got stuck in the mountains
Yeah, and
and
they eat each
they
other.
couldn't get out.
That's so
So they
gross.
eat each other.
Yeah, I will never.
The Donovan
It just
family.
tastes
was
like
them.
Remember that one team that got stuck in Indy?
I don't know why. I mean,
The what?
I guess
The
it was
one,
healthy,
the
yeah,
sports team got
I
stuck in
didn't
Indy
know.
because there's a water
Oh,
crash also.
yeah.
She'll pass me through that.
So you're right.
Are you sure it's the Donovan? It sounds different. I don't remember.
I think it was the
Eating the
Donovan.
food you already ate.
Alright, so pyroclastic material, the video mentioned this as well, consists of fragments ranging in size from very fine dust and
Donner.
ash.
The Donner Party.
Donner. I was close, but you're right, Donner Party. There you go. Volcanic ash to pieces that weigh several tons. So if the whole top of the mountain blows off, you're gonna have these big, huge chunks of rock that get flung out of the way. Or you can get little pieces. So it really just depends. But you're gonna have some of this pyroclastic material, pieces of rock, pieces of ash, that get thrown quite a distance when the eruption initially happens.
What does the picture of the corn have to do with that?
It's giving a comparison
Oh.
that some pieces can be larger and some can be quite small.
Okay, I was confused.
Yeah. A lot of times they'll take pictures with a piece of money or something in it to compare.
I like how circular these rocks are.
It is kind of neat. They all look really circular. I wonder if that could have been because they tumbled down the side of the mountain and kind of
Eroded.
eroded the edges. Huh?
So we should all relive okay. You know how many freshly preserved bodies are hidden under that ash?
Mm. Especially if they're bodies.
Alright, so here's another video kind of showing how the ash fall can be dangerous, not just the explosion and the lava, but the ash is something you need to be prepared for as well.
Just ask it now.
What should you know about the potential impacts from ash fall? Jen Moniza found out. Jen?
Joe, according to the USGS, ashfall can impact us in numerous ways. More ash equals more potential hazards. So the amount of ash released into the air from Halemaumau will determine how serious the matter is. The ash plumes on the Big Island have many concerns. The big question is, what will happen if you inhale the ash?
Ash is particulate matter that blows out of the vent, can cause irritation and basically an acid burn of the lung, which causes a lot of coughing and wheezing and respiratory distress.
What can people do to prevent and protect themselves from the ashfall?
The most effective thing is to move out of the area where the ash is falling.
think?
But what if you can't do that? One of the easiest ways to reduce the health risks associated with ashfall is to use one of these. It's a particulate mask and it goes on pretty easily. You can get these at any neighborhood drugstore. Brady also suggests staying indoors in an air-conditioned room, avoiding outdoor exercise, using an inhaler if you're having bronchial spasms, wheezing, or excessive coughing. He also says seek medical attention if symptoms persist. The ashfall could potentially impact other things, like electricity.
A light dusting of ash in combination with moisture on our insulators could cause electrical short circuits, and that could result in power interruptions.
Hawaii Electric says it is ready to respond if this happens, but it could be worse, depending on how much ash there is.
If this is a widespread situation, power restoration may take longer.
They tell me they are monitoring the situation closely and advise the public to follow civil defense alerts. If ash gets into your water catchment system, Dr. Brady says, avoid drinking it. Drink bottled water instead. I also spoke to Impact Auto in Kona. They say it's important to keep the engine and air conditioning filters on your car clean. Ash could clog your intake filters, potentially causing your engine to overheat or even allowing the ash in the air to get into the cabin of your car. Joe?
So a lot of things that you didn't even think of. I didn't even think about, well, okay, car air filters. That's going to be a problem too if the ash starts to fill the area.
Just ride a bike.
Just ride a bike. But you're not supposed to be outside, it says. So.
Some fly by it.
All right, so that's all the information we're going to talk about today. We have covered quite a bit. We've talked about earthquakes. We've talked about volcanoes. We're probably getting, I don't want to say super close, but our test is kind of on the horizon. So just kind of be keeping that in mind that before too awfully long, we'll probably have our test. Today I want you to continue to work on the reading assignment, the ocean floor reading, and then we will work on the lab, which I will pass out here in a moment. Remember, there's a lot of the lab that you need to do in advance to decide what your experiment looks like. Which soda are we going to use? How are we going to test this? How are we going to measure it? How are we going to set this up? All of that needs to be thought of beforehand. We can't just go out and blow up soda. I mean, it'd be fun. It's going to be fun. But we need to have a purpose behind it, and that's what this is starting to do. Now, in this lab as well, there's a second part. And the second part of the lab is something we'll do in here. It requires a hot plate, so that's called the volcano in a cup, and we will do that one together, just not right now. We'll do that after the Mentos and soda one. Any questions? That's fine. Ocean floor reading is due tomorrow, so make sure you're getting that done first.